Alright, so today's lesson deals with the trapezoid rule and some of the different things that we can get from that. And one reason that the trapezoid rule is really nice is if you've got some curve, let's say we've got this curve and it looks really cool. It does, something like this. And what we've talked about so far is rectangles, right? Using the area of rectangles. But if I can instead use a trapezoid, so instead of making this rectangle and leaving all this open space above my rectangle, or the space that doesn't get used inside the rectangle, like so this space right here, or this space right here, this is error space. What we can do is with a trapezoid, we can actually create a trapezoid shape that really eliminates a lot of wasted space. And so when you look at these guys, there's not near as much wasted space in each trapezoid. And so it almost is, it's not almost, it is a lot more accurate of a measurement than using the straight up area of rectangles. So it's called the trapezoid rule. And what we do is we figure out h, okay? And h is where you stop minus where you start divided by the number of intervals, partitions, trapezoids, okay? And it's stop minus start. So we're going to take this h value and we're going to multiply it with the height of y0. Y0 would be your height at that first spot. We're going to check it with 2 times the height at y2 plus 2 times the height at height 3 of y3, and all the way and so on and so forth all the way through. So it looks really confusing, but it's actually not that bad. So let's say we've got y equals x squared here. We're going to go with y equals x squared. We're going to go with n equal to 4. So using our formula, and we're going to go from 1 to 2. So a is 1, b is 2. So what is h? H is going to be 2 minus 1. 2 minus 1 over the number of intervals, which is 4. Okay? And so now we just need to figure out y0, y1, y2. And the way to do that is at y0, we've got to figure out, well, where is y0? Well, it's our very first height of our rectangle. So in this case, our very first height is going to be when x is at 1. And if we go from 1 to 2 and divide that into 4 different intervals, then I'm looking at different x values. X equals 1, which is 4 over 4. X equals 5 over 4. X equals 6 over 4. X equals 7 over 4. And those are the 3 intervals there. And then the final interval would be that 4th rectangle, y4, which would be then when x is equal to 2, or trapezoid. So here's y0, here's y1, here's going to be y2, here's going to be y3, and here's going to be y4. Okay? So how does all this look? Well, I set my trapezoid rule up to be t equals, and then I do h, which is 1 over 4, divided by 2. So 1/4 divided by 2 times, and then y0. Well, that's when x is 1. So what do? You take that 1 for x and you put it in here for y. So y squared, y equals x squared. That's 1 squared, which is 1, plus. And then take 5/4 and put it into x squared. So that's going to be the number 2 times 5/4 squared, 25/16, plus the number 2 times 6/4. Well, let's reduce this and make it a little easier to look at. That's 3/2 squared, which is 9/4, plus 2 times the next one, which is 7/4 squared, 49/16, plus the very last guy squared is just 4. Alright, so what you have is 1/8 times 1 plus 50 over 16 plus 18 over 4 plus 98 over 16 plus 4. And when you punch all that into your calculator and add it all up, what you're going to end up with is 2.344. Let's go ahead and round off at 3 decimal places. So, there's no need to figure out all this by hand. Use your calculator to help you out. But you're going to get this for your area. And this is an area approximation. Okay, this is an area approximation. And what we can do is we can actually punch this integral into our calculator. So we're going to look at the integral from 1 to 2 of x squared dx. And what is it that you get when you do that? And when you punch this into your calculator, you're going to end up with 2.3 repeating. And if you'll notice, the approximation that we got is really a good approximation. It's pretty close, pretty accurate. So this is how the trapezoid rule is used. And if you're having trouble with the trapezoid rule, like remembering all these little steps, basically what you're doing is this. You're getting a trapezoid rule is equal to your LRAM, your left area, left rectangle approximation method, plus your RRAM, right rectangle approximation method, divided by 2. And so that's basically what you're working with. So anyway, practice these problems out. They're not horrible, but they look long. But just hang in there, and they take care of themselves. Okay, so an observer measures the outside temperature every hour from noon until midnight, recording the temperatures in the following table. So starting at noon and going all the way to midnight. And then using calculus, what is the average temperature? And there's the average temperature formula. So again, you cannot use the normal averaging method that you may be comfortable with. We're going to use our calculus and really practice here. So this is what we've got. Well, we don't have an equation to work with, really. So what we're going to do is we're going to take this guy and break it down into the trapezoid method. And notice we've got the heights of all our trapezoids, okay, from beginning to end. We've got all the heights that we need. And so the trapezoid method then is going to give us a really accurate look at what this guy's going to look like. So let's just go with the trapezoid method real quick. So T equals, and then the H divided by 2. Well, what is H? Well, if you go back to the to your notes, H is equal to where you stop minus where you start divided by the number of intervals. So we're looking at stop minus start. We're looking at a total of 12 hours here. Okay, and then we're looking at a total of 12 intervals, and that's going to all be over 2. So and then times all the different heights, 63 plus, and then don't forget on that second one it's 2 times 65 plus 2 times 66 plus 2 times 68 plus 2 times 70 plus 2 times 69 plus, and then we're going to go all the way up to plus 2 times 62 plus 2 times 58, 2 times 58, and then plus 55. So we would punch all of that into our calculator. So what you're going to end up with is 12 divided by 12 is 1. So your H value, this value right here, is going to become a 1/2. Okay? And so what you're going to have is 1/2 times everything inside your parentheses. And put that in your calculator, add it all up, and multiply by 1/2. And what you're going to find is that t is equal to 782. Now, that's the entire area under the curve. Well, how many different pieces of area are we looking at? So now we need this 1 over b minus a part. So for the average then, the average of f, we're going to have 1 over b minus a times t. So I stopped at 12 noon. I started at 12 noon, but think about this now. How many hours of time went by? So it can't actually be 12 divided by 12, or 12 minus 12, because that would be 0. But how many hours went by? Well, 12 total hours. That's how many different interval pieces we're looking at. Times then the 782. 782. And so when we do this, and you punch that into your calculator, this is going to be about 65.17. And so what's your average temperature then using calculus? It's this right here. So if you're asked to use calculus to find average temperature, then show those steps, show trapezoid rule, show an integral, and make sure that that is really what you're using. Alright, a rule very similar to the trapezoid rule, and they're often mentioned together as Simpsons Rule. And it's a little bit different, but it does a lot of the same stuff. So again, you've got this long process here, but some things don't change. Like, for example, finding h. The h doesn't change. It's going to be stop minus start divided by the number of subintervals that you're going to have. So that's the same. Okay. The difference now is I'm going to divide by 3 instead of 2. And then when I look at each height of each partition, notice I'm going to start with my initial height, but then I'm going to do 4 times the first height plus 2 times the second plus 4 times the third. And you follow that times 4 times 2 pattern all the way till you get to the end. And you need to end it with the 2 times and then a 4 times and then just the final guy. So same steps. Okay, same steps, but different numbers in front. Okay, so use Simpsons Rule to approximate the following integral. So a is equal to 0, b is equal to 2, h is equal to b minus a over n, and n is 4, so b minus a over 4, which is 1/2. Alright, and then we want 4, so we're looking at y1. So in other words, when x is 0, y2, when x is 1/2, y3, when x is 1. Let's see, this would be 0, 1, 2. I got off by just a little bit. 3 is when x is 3/2, and then 4 when x is 2. Okay, so when you put these numbers in for your heights, so what are you really doing? Well, this is a little bit more complicated than the first one. So on each one of these, we're going to have 5 times 0 to the 4th. That's going to be 5. So here's y0. We're going to have 5 times 1/2 to the 4th. That's going to be 5 times 1 over 16. That's going to be y1. y2 is going to be 5 times 1 to the 4th, which is, wait a second, this guy right here should be a 0. This guy right here is going to be 5. Then I'm going to have 5 times 3/2 to the 4th. And that's going to be 81 over 16 times 5. That's your y3. And then the last guy is going to be 5 times 2 to the 4th, which is going to be 5 times 16, which is y4. So when you're setting this particular guy up, those are the numbers that you're going to use. So you're going to have let's go with a big S here. S equals 1/2 over 6 times, and then y0, that's just going to be 0, plus 4 times 5 over 16, plus 2 times 5, plus 4 times, and then 81 over 16 is 5 times 81 is 40, 405, so 405 over 16. And then finally plus that very last guy, just the last guy only, and 5 times 16 is 80. So here's your math on this particular guy. Don't forget that when you work out 1/2 divided by 6, or 1/2 divided by 3, shoot, 1/2 divided by 3, I got all ahead of myself. 1/2 divided by 3 is 1 over 6. So it's going to be 1/6 times all of that stuff, and then just punch it into your calculator. And most calculators will give you a fraction answer on this because it's not too bad, but 385 over 12. And if you don't have that, so it would be 385 divided by 12, 32.0833. And again, we would usually round off at 3 decimal places, so you don't necessarily need that guy. But Simpsons Rule is just super duper similar to the Trapezoid Rule, and they're both really easy to work with.